So to comment, the first thing you have to do is to open up your staad environment. So staad.pro is structural analysis and design. Structural analysis and design is an excellent application developed originally by Research Engineering Institute before it was purchased over by Bentley Suits. staad is an excellent finite element analysis package that permits you to carry out several types of engineering analysis. You can carry out structural static analysis, linear elastic analysis. You can carry out non-linear elastic analysis, that's to say deformation of the structural cross-section as loads is applied to the structure and it reaches its yield point. The cross-section changes. These are non-linear elastic analysis. You can perform plastic analysis with staad, buckling analysis, lifting analysis, dynamic structure analysis, and even pushover analysis. It has an excellent engine that can develop the various structural stiffness matrices of each model entity you have modeled, beams, columns, plates, and then aggregate the stiffness matrices in the local coordinate system, obtain the stiffness matrices in the local coordinate system first of all, then aggregate the entire stiffness matrices in the global coordinate system via the use of the transformation matrix, and then it carries out the solver with the use of Gauss elimination method. For dynamic analysis, staad will get both the mass matrices and the stiffness matrices, and then perform a time step linear elastic analysis to linear dynamic analysis for the purpose of extracting the eigenvalue values, which are the various natural frequency of the structure, and then the eigenvalue solutions, which are the modes of vibration of the various structures. That reports the amplitudes of vibration for each discretized time step solution. It also reports the periods of vibration, the cumulative natural frequencies, as well as the various mode shape, by solving the partial differential equation that represents the deformation of a structure under excitational forces. Today we will have to just explain the environment very rapidly. When you get to staad, this is staad V8i. We are using staad V8i for this analysis. We want to model the entire structure, load it, and analyze the structure. So you would first of all start a new project, new. Now when you open the environment, the dialog box comes up. There are 4 options: space, plane, floor, and truss. For space structures, you can develop and load the structure in any direction. The inherent solver develops a stiffness matrices in the 3 orthogonal directions. So for each element you model, it has about 3 linear degree of freedom per each node and 3 rotational degree of freedom per each node. So it automatically has 12 degree of freedom for each element. So for space structures, it means it can move in the X, Y, Z. It can rotate about the X, Y, Z for each node. So you have complete 12 degree of freedom for each element. So a 12 by 12 stiffness structural matrix is going to be developed for each element. Plane structures are structures that can be loaded only in plane. If you specify a plane structure by ticking the box, it means that you cannot load the structure out of plane. You can only load it in plane, and then for each element there's a 2 degree of freedom. It can move. If it's an XY plane, it can move only in the X and Y, or it's restrained in the X and Y. It can also rotate in plane, so you have a 6 degree of freedom per each element. So you have in plane deformation and then in plane translational degree of freedom. Floor structures, and when you're designing structures like slab, you have in plane degree of freedom and then out of plane rotation. And then truss structures are typically axial only type of structures. So staad gives you the opportunity to select the type of structure you intend to model, and because you are analyzing the entire whole 4-story structure, we are selecting space structure. So give it a title. In this case is design of a 4-story structure. Select your units correctly. Your unit has to be accurate, correct. If you either use imperial units or SI units, so we're using SI, meter and kilonewton, and then the location where we want to store what we are doing. I've created a folder for this analysis. You store it wherever you intend to store it. I'm going to where I want to store this file. Okay, so file name, design of 4-story structure, location there, and then say next, and then finish. The environment opens up. You get to see the interface. The interface comes up, as we can see. Take this off. Okay, so the interface comes up. So what you want to do firstly is to put a description of your project. You can give it a job title. If it's a formal project, you have a job contract number, you put that there. Your client, you put it there. Job number, revision 1. As you make changes to the structure, you update the revision 2, 3, as the case implied. The engineer's name, you can put your name there, engineer Ken, Roy, whoever it is, the checker, and whoever approves the drawing. You move to the environment. So this is where we're going to develop our structural model. Now the grading system permits you, gives you an excellent avenue to create your model within its defined environment. So you can always modify this grid system. Here you have about 10 grids, each spaced at 1 meter. It is being modified here. So if you want to change this to 20 grids, for example, you come here, you can see in the X and Y axis we have 10 grids. If I say so you have start, end, both. So if you want both to be displayed at the both the top and bottom, you say both in the X axis. If you only want start to be displayed here, you change that to start. Now we can edit the default grid. Okay, before I go to the edition, so we just talked about starts. You could do the same thing. On the X axis we said start, end, or both. So if you say start, it will show the coordinates, the X axis at the start location. It won't show that on the end. If you move to end, it will show it on the end. Same on the Y axis. So if you put both of them, start, you get to see the coordinates shown in the X and Y axis of each of the grids, reference to the origin of the entire graphical user interface. Now when you come to edit, so we can change this, because if our structure is larger than 10 meters, remember your units are in meters. If you are in doubt or you are forgotten, you could always come here, input unit, you could see meters and then kilonewton. So everything you're defining is a metric unit. So if I want to change this grid to 20 grids along the X axis, I come here to edit, right, if I put that 20, you see it changes to 20 automatically. The same thing in the Y axis, if I put that to 5, it changes to 5. So this is the way you can modify the grid to suit what you intend to do. Okay, now for the purpose of what we are doing now, let's go back to the analysis model, the first floor structural layouts. How do we commence this model? You have to be very, very careful in your modeling. Okay, I'm going to start from this location now. Okay, C2, this goes to be my origin. Now this is the first floor structural layout. You can see that it's on the X, so relative to the start environment. Let's go to isometric view. So this is X, Y, and then Z. Z points in an isometric view. So I can always rotate this. Okay, as you rotate it, you could see that this is also rotating as well too. So you have X, Y, and then Z is pointing towards your screen. So if I want to model the first floor, I have to change this grid to the XZ plane. You can always alter the planar location of the grid by changing the plane in which the grid is displayed. If I say XZ, it comes that way. If I say YZ, it goes in the YZ plane. Okay, so you have three mutually perpendicular planes, X, Y, YZ, and then XZ.